Hello. All right. So today we're talking about congruence in overlapping triangles. So this is not a difficult subject, but it can be very confusing when you have overlapping triangles. So what is the common angle in example one? It's talking about the common angle. So when we have overlapping triangles like we do here in example one, we're almost always going to have a common angle or a common side, a side or an angle that they both use. So if I'm looking at triangle LMP and triangle LNO, one thing I like to do is draw the triangles separately, first of all. So LMP would be this triangle. So I could draw that. It looks something like that. So this is M, L, and P. And then LNO. So that's L, that's O, and that's the N. So it's asking what's the common angle in LMP and LNO. There's a couple different ways I can do this. I can draw them separately like this and see, well, which angle do they both triangles have? Obviously that's L. So L and L are going to be congruent. You can also look at the letters. So if you're looking for the common angle, which is the only letter that they both have in common? So again, it's going to be L. So angle L will be the common angle. And then they ask, what are the common sides in MON and NPM? So MON, if I redraw that, I'm going to do that over here. So MON, and then I'm going to redraw NPM, so NPM, so N, M, and P. So which side do they have in common? MO, no. ON, no. MN, yep, they both have MN. Again, another way to do this is if you're looking at the common side, which two letters do both of the triangles have? They both have an N and M. So NN would be the common side. So that's example one. So these are our two answers right here. Oops, fix that. So in example two, oh, we got a proof, yay. I know you guys are excited. So our statements go on the left, reasons go on the right. So first thing we always do is write whatever's given to us. So RU is congruent to TS. And they also give us that V is the midpoint of US and RT. So that's also given. So those two pieces of information are going to be very useful for us. So the first thing, RU is congruent to TS. So RU is congruent to TS. So we know those two sides are congruent. It also says that B is a midpoint between US, so US is this line right here. If that's right in the middle of U and S, that means that this line segment, UV, has to be the same as VS. And if V is the midpoint of RT, V has to be right in the middle of R and T, which would mean that these two lengths have to also be congruent if V is right in between them. So now we have a lot of sides are congruent here. Remember, our goal is to be able to prove that RUV, angle RUV, is congruent to angle TSV. So RUV would be this angle, TSV is this angle. So some of you may be thinking, well, those are alternate interior angles. Can't we just say that? We cannot use that because they are alternate interior angles, but we don't know if they're congruent because we don't know if these lines are parallel. So that's why we can't say that. But we do know that this triangle right here is congruent to this triangle. And how do we know that? Hopefully you're answering. So triangle URV is congruent to triangle STV by the side postulate. So hopefully when I asked that question a few moments ago, you were thinking that because we have three sides. So RU and TS were a side, and then the V being the midpoint created two other sides. So we got three sides, so side postulate. So now that we know those two triangles are congruent and we're trying to use one of those angles in each of those triangles, we can prove that the two angles are congruent. So angle RUV is congruent to angle TSV. So if the two triangles are congruent, how do we know that angle is congruent? By CP/CTC. So again, CP/CTC is saying if the two triangles are congruent, then we know all the corresponding parts of those two triangles have to be congruent as well. All right, so example 3, we got another proof here. And this one